Christina. Welcome everyone to the last day of Earn Conversations 2020. Welcome back if you've been at the training so far. We're glad to have you all here and appreciate you all coming back for more training. We're really excited about this. So just a few quick housekeeping announcements. We are recording this session again so that we can send it all out for you to use as a reference. But still feel free to, ask questions just as you usually would. And also if you could just take a moment and change your name to your name, first and last, your preferred pronouns, and your organization, just so we can identify everyone, and I will do the same. And then the last thing is that we are really trying to make these trainings as useful as possible, whether they're in a virtual or in-person format. And so we ask that everyone take a moment to fill out the evaluation form so that we can improve these sessions going forward and refine them to be as useful as possible to the network. So I will turn things over now to our instructor for the day, Zane.
All right, hi everyone. If you weren't at the last session, my name is Zane Mokhiber. I'm a data analyst at EPI. And this is the second Stata session. I'm calling it Using Stata Effectively. Quickly before we start, I just wanted to say that this is essentially just an builds off all of the stuff we learned in the first session. So it kind of assumes you have a little bit of knowledge from either the first session or you've maybe used Stata a little bit before. Okay, so let's jump right into
even on the computer, it's super quiet.
Sorry about that. So the motivation behind this session is to teach you how to analyze microdata effectively and efficiently. So learning these skills will allow you to answer questions you might not be able to otherwise answer using published data, whether that's from BLS or census or maybe EPI specific data sets. And I'm kind of going to put the emphasis here on file management and reproducibility, meaning we're going to talk about how to set up your projects in a way that make it really easy to reproduce them in the future or hand them off to others and allow others to easily replicate your analysis. And I'm also going to focus on how to use do files properly. So like I said, the overview for this session, these are kind of the learning outcomes. We learned how to write do files in Stata using best practices and proper documentation. I'll go over some intermediate Stata operations like joining data sets, that's merging or appending data sets, transforming data. I'll talk about macros and loops and how to export and pool multiple years of data together. And I will also, throughout the whole thing, I'll talk about like kind of the best practices on how to set up a project with like a directory structure and working directories and storing raw data. And I'll also show you specifically how to use the EPI data resources, like the EPI CPS extracts and some of the tools that we've created to make those really easy to use in Stata. So the format for this lecture also will basically just be working through a do file, which is this one that I've posted at the Data Bootcamp website. So if you need a reminder on where to find that, that is here at economic.github.io/data_bootcamp. And all of the files for this session are stored here, including a couple of data files that we'll be using and the do file, as well as the slides. Okay, so I just wanted to start out with this chart, which is an example final product. Maybe it's a chart that one of you would end up creating for a blog post or a report. And basically what this chart shows is the average hourly wages by race and sex in Ohio. And it uses pooled data from 2017 to 2019 in the EPI CPS, and it's inflation adjusted for 2019 dollars. And so just so you all have kind of like an end goal in mind of what we're building towards while we're working through this do file, because it's not necessarily like chronologically in order in the way that I laid it out in the overview, but it should, if you keep this in mind, it kind of should make sense as we're working through it as to why I'm doing certain things in a certain order. And this is just was created in Excel. We're not going to actually be creating this graphic in Stata itself, although you could do that if you wanted to. I don't think we're going to have time to get into that today. Okay, so I'm talking a lot about do files. If you don't know what a do file is, basically it's just a script or a regular text file that Stata can read and then sequentially run all of the commands that you place in a do file. And the reason it's called a do file is because it has this extension .do. And the reason we write do files is because it's a fully documented record of your entire analysis. It makes your work easy to reproduce and easy to update in the future if you need to, or if you need to make modifications. And it's also really easy to see where mistakes might happen, and it makes it easy to make improvements to your code. So once again, I've created this example do file that we'll be working through in this session. So if you want to follow along, please download this do file. Okay, so the first thing to mention is you always want to document exactly what your do file does. And the way you do that is with comments. So a comment is essentially just a line of text that Stata ignores. So if I open up this do file here, oops, this do file, which you can open directly from Stata with the file open command, or you can go to the new do file editor. Whoops, that's the data browser. The new do file editor, and then you can open it from here as well. But I already have it open. And basically a comment is just an asterisk and then the text after that asterisk that you want to not be evaluated by Stata. So you basically can put as many comments as you want, and they're a really good way to document exactly what you're doing and let other people know, or your future self know what you're doing. So in the preamble here of my do file, I have what the file name is, a short description of the file, and my name so people know who wrote this analysis. There's also a couple of other ways to write comments. Specifically, a comment block is useful, and so that's just a slash asterisk and then whatever your comment is, and then another asterisk followed by another slash. So that allows you to create comments that are on multiple lines. So one way I could modify this would be to get rid of the individual asterisks and place the comment block around the whole section of text. So if you have a lot of text that you want to comment out, comment blocks are a useful way to do that. So I recommend always adding comments to your do files, and add as many as you can, even if it's redundant, because you're 100% going to forget what a do file was doing when you go back and look at it in the future. So the more comments, the better. As you can see, this do file here has quite a few comments in it. Okay, and then the other thing that you usually want to put at the beginning of a do file are these two commands, set more off and clear all. So what the set more off prompt does is it's kind of a weird thing in Stata, but there's a setting called more, and basically what that means is if you try to run certain commands and display them in the results window, if it's too much information, Stata is going to have a little prompt that says click here to see more of the results. And if you're running a do file that's pretty long, that can be annoying because you have to click in the results window every single time. So we turn that off, and then we clear anything that might already be in memory, like datasets or some other stuff like macros. Okay, and then the other thing to do before we continue is to make sure that the working directory here is set properly. So if you were following along from the last session, I suggested that everyone create a directory where where you store all these files, the do file and all the relevant data files. So I created a directory here called data_bootcamp, and it has the 2 do files that I was using and the various data files that I'm also using to conduct the analysis. And so we want to make sure that our working directory is set to this location. So I can do that in Stata by typing cd and then copying and pasting that directory name. You can also just go to File and change working directory and then select it through the browser window here. So that's the kind of first few things that you should do when you're setting up a do file. And just to talk a little bit more about the working directory, you always kind of want to make sure that a project is self-contained, except for a couple of exceptions, which I'll talk about here. But you want to make sure that your do file and your data files are kind of relative to that root project directory. Okay, and then this is just going over the analysis from session 1. So this is all of the stuff we learned about last time, and I've just included that at the top of the do file here. So that goes up to line 21. But basically, if you don't remember already, we used the EPI CPS org in the 2019 version of the EPI CPS org to look at wages in Ohio for people who are older than the age of 16 by race and gender. And then we exported that to Excel in the last session. So that's kind of how far we got last time around. One quick thing that I didn't get to show you last time that I wanted to include in this session was the output last time wasn't super useful in terms of creating like a graph in Excel, or maybe we would want to do some, calculate some wage gaps or percent differences between the various groups. So if I just run this section of the code real quick up to the collapse command, and I can do that by highlighting it and clicking the execute button here. If I look at this data set real quick, you can see that we have 3 variables, the female variable, the race variable, or WBHO, and the average wages for those various groups. But this is what's called, this is in what's called long format. Basically what that means is that there's a value variable and then kind of identifier variables for what those values are. But if we wanted to copy and paste this into Excel or export it to Excel, it's kind of not the most useful format to have this data in if we're going to do other stuff with the data, like create a graph in Excel, like the example, the one that I showed you. So what we can do is what's called reshaping this data. And we want to reshape it specifically to a wide format, so the values can be added and subtracted from each other. And the reshape variable, or the reshape command, is a little bit confusing at first, so I'm going to slowly walk through everything, exactly how to use it. So the first thing that I typically do when I'm using reshape, because I don't always remember exactly the proper way to use it, is just use the help command, honestly, in Stata. So I'm going to type help reshape. That brings up the help page here. And this image in particular is very useful. So it tells us if we want to go from long to wide, the syntax goes like this. We have the reshape command and then the data shape that we want to convert it to. So in this case, we're going to go reshape wide. And then what they call the stub here. So in this case, that would just be the wage variable. And then the I and J variables we include in the I and J options. So let me see if I can zoom in on this a little bit. I don't think I can. But basically, we have an identification variable and a J variable that will end up going along the top here and become the new variables combined with the stub, which in this case is wage. So let's just do this as an example real quick, because that'll kind of clear things up on what I'm talking about. In this case, we've put wage as the stub, female as the I variable, and WBHO as the J variable. So if I run that, you can see something happened. And if I look at the data, whoops, if I look at the data again, you can see that now there's only 2 observations and there's 5 variables. And our data has been reshaped so that race is across the top now with in the columns. And then we just have a row for male and a row for female. And so as you can see, the values from WBHO just ended up getting appended on the end of this wage variable here. So, or the wage variable name. So this is, for example, is wages for white people. This is wages for Black people, etc. And since that's kind of not the most descriptive naming convention, I'm going to rename all of those variables to their actual names. Okay, so we can look at this one more time. And now we have a nice table that we can export to Excel or do whatever we want to with. And it's clear. It's a lot more, clear what's going on here. And when the table is this small, it doesn't really matter, but it's useful in a lot of instances to reshape your data. So I just want to reiterate that reshape is not super intuitive all the time. So just use this help file. Don't worry about remembering exactly what J means and what stub means and what I means. Just use the help file whenever you have to reshape something. And if you can't get it from the help file, Google it. There's a lot of useful Google resources. Okay. Okay, so that covers the reshape, and I guess I should quickly talk about the rename command. If you've never seen the rename command, that just takes a variable name and renames it to something else. So the syntax is just the name you want to rename, the variable name you want to change, and then the name you want to change it to. Okay, and then we covered this in the last session, but I'll just go over it really quickly here. So I'm exporting this data to an Excel file, and the syntax goes export Excel, and then using the name of the file you want to save it into, and then this option, the comma here for the options, and then the options I'm adding are replace, I add replace since this file already exists, so I want to overwrite it. And then first row variables just saves the variable names in the first row of the Excel document. So that's pretty straightforward. So I'll run that. Whoops. I'll run that next. Okay, and then we can see that this file has been saved in our working directory. Okay, so it's possible that we would want to look at multiple years of data. Like maybe the sample size that we are looking at isn't really large enough for, especially when you're looking at things by race and gender. You can get down to really small sample sizes in all those cells. Or maybe we want to view changes over time. So we would have to look at multiple years of data in that case. And so what we can do is we can join data together using append, and we'll get to that eventually. And the general rule of thumb for sample size concerns is if a sample is larger than 1,000, so if there's more than 1,000 people in a certain sample that you're looking at, it's fine. And if it's smaller than 500, you might want to take a closer look. So you could use tabulate or count to investigate that. So in this case, we could add, before we collapse this data here, we could say tab WBHO and female. So I'll just run this from the beginning again. Let's do it like this actually. Okay, and we can see there's some pretty small counts in here. Like really all of these sample sizes, you might not really trust the results for average wages, especially for Hispanic in this case. You might come across this if your state is smaller. Like typically the only states that sample size really isn't a concern is like California or New York or Texas or something like that. So especially in the CPS, which is kind of a smaller survey than some of the other surveys that we use. So what we need is more data. So instead of just using the 2019 data, is we're gonna add a few more years of data together. So before we get to how to actually stack those data sets together, first we need to actually access the data. So I had asked people to download the full CPS org data set from the microdata website. So if you're following along, hopefully you've done that, but if not, you can download it from this site here, which links the CPS org data from the microdata website, or you can just download it directly from the EPI microdata website, which is just microdata.epi.org. And it's this last zip file here. So if that's been downloaded, then and unzipped, then great. Then you'll have that in a location on your computer. And generally the way that we do things at EPI is we kind of treat this data as read only. So we store it in a central location and always access it from that one location. This has a lot of benefits. So like that raw data is always the same. Like we don't have to worry about that data changing or moving to a different place, which helps with reproducibility. And it also saves space on your computer by, like, if I had downloaded this data directly to the data bootcamp folder, and then say I had another project that used the CPS org, I would be duplicating those data files in a lot of different locations when all of the data is exactly the same, and I just need to like run some scripts on it to get the output that I want. So what I've done on my computer is I've created a data folder under C data at CPS, and I've extracted it there. So what you can do if you've downloaded it is you can actually just create that file somewhere on your computer, and you don't even have to extract it. You can extract the zip files with your computer's zip utility. You can actually just use Stata to unzip the files. So the first thing you would want to do is change the directory to whatever that data folder, whatever you've called your data folder, and then use this command, the unzip file, and then wherever that zip file downloaded to. So in my case, it was downloaded to my downloads folder. It will unzip the data, and then you can change your directory back to your current working directory. So you could also just do it within a file explorer with the zip utility. I just wanted to show people a simple way to do it within Stata, just to let you know that Stata actually has that utility. So if you've done that correctly, I can, oops, that's not what I want to do. I'll just show you what that looks like real quick. Okay, so I have a folder with all of these stated data sets stored in it. Okay, so again, we'll get to how to actually append everything together, but I wanted to kind of do this in the order that we have it in the do file, so people aren't too confused about what's going on here. So before we actually get to appending the data together, I wanted to talk about another kind of best practice, and that is to use what are called macros in Stata. So what macros allow you to do is they basically just store information in what's called a macro, and you can declare macros with this command here, the local command. And basically, we're just going to deal, there's a couple of types of macros, local and global. We'll just deal with local macros for now. But basically the syntax is pretty straightforward. It's just the local command, and then whatever the macro name that you're coming up with, and then whatever you want to store inside of that name. So I'll just do like a really silly example. In Stata, I can create a local macro, and I'm going to call it my name. And then my name is Zane, so I'm going to type Zane. And then I can, now this macro has been declared, I can refer to it later on. So if I want to display it, I can use the display command. And then the way you refer to a macro is with the tick mark and then an apostrophe. So the tick mark is just on the tilde key on most keyboards. And then I'm going to say my name here. I'm going to put it in quotes actually, just because it's a string. And so I displayed the macro my name, and my name Zane showed up. So another example here is the one I put in the slides. Maybe you want to create a macro called current year. You could do that with local current year, and then we're declaring that as 2020. You could display that current year, or you could subtract and add things to current year. So you could imagine like a do file where you want to refer to years relative to the current year. You could use current year and then add and subtract years onto that. So macros are really useful. And in this case, we want to store the file path to the data. The reason we want to do that is perhaps the file path is different on different computers. So if you share this project with with a colleague. Maybe they have their data stored in a different location. And if we wanted to use various files from the data file or the data folder that we've created, we'd have to type that data file out every single time. Since it's not in our working directory, Stata is not going to know where to look for that data. So instead of doing that, we're going to just declare a macro once that has the file path for the data. So we're going to create a local macro called data_dir for data directory. And we're going to type the file path on my computer, which is data CPS. So if I run that, now that macro has been set. And then we can replace where the file path would normally go with the macro. So I'm going to say use and then refer to the macro that we've declared called data_dir and then the name of the file that I want to use. So this is the same file that I have in my local directory. It's just stored in a different location. So if I if I run that command there, now I'm using the 2019 CPS org file, just the one that's been stored in the data CPS directory. So that's pretty useful because if I ever needed to change, and you can see like later on in the do file, I use this data_dir macro a lot, but perhaps I move those data files somewhere else on my computer, I could just change it once here and it would, the do file would still work properly. So that's why macros are so useful. And that's just one use for them. There are many uses for them. Okay, so now we'll get to appending the data. We're kind of at a point now where we can actually load all of the data files that we're going to need to pool a couple of years together. In this case, we're going to pool 3 years together. We're going to pool the 2017, 2018, and 2019 CPS org data together so we can overcome that sample size issue that we were having earlier. And basically, we're just stacking the data sets on top of each other to create one large data file. So the way you do that is you use the first data file that you want to use, and then you just use the append command. And the syntax for the append command is just the word append, and then using, and then the path to the file that you want to append, and then the file name. So let's go ahead and run that in our do file here. And I'm going to have to it's actually okay. So now if I look at the number of years in my data set, we can see that there are now 3 years of data instead of just the 2019 data. And we can again run the command that we ran earlier, tab wbho and female. Oh, well, I would have to restrict to Ohio first. Forgot to do that. Okay, and we can see that's a little bit better for our sample size. It's still like less than 500, but for the purposes of this exercise, I think this is fine. So let's move on here. So if we want to calculate mean wages to get that picture from the example picture from the first slide, we can't just now take the average wage across 3 years because of inflation. We actually have to adjust for inflation. So to do that, we're going to need to merge in some sort of inflation adjustment value. In the case of EPI, we use the BLS CPI URS, which is the research series. So you can get that from this link here. I've included it in the slides, and I've also included the Excel file on the Data Bootcamp materials page. So this actually is outdated, but I changed this from a CSV file to just actually to read the Excel file directly, because I figured that would be a little more useful to learn how to do. So ignore the slides for now, but this Excel file that exists on the Data Bootcamp website is called our CPI URS all items, and I'm not sure exactly what that stands for, but it's basically the CPI URS data. So I'm just going to open it up and look at it real quick. And because we're going to calculate we're going to use the yearly averages here to adjust the average wage values, we really only need the data in column N. So I'm going to show you how to read that Excel file into Stata and then make some modifications to it so it's easily saved, and then we can use that in our analysis later on. So the first command to get it into Stata is called the import command, and then in this case we're importing an Excel file. So we say import Excel using the name of the Excel file, and then there's a lot of stuff here at the top that we don't really care about. We really just want the data itself here. So what we're going to do is import a cell range, which is an option that we add here. We say import the cell range from A6 to N49, and import the variable names as lowercase variable names, because actually Stata variable names are case sensitive. So just for ease of use, I'm going to make it all lowercase. And then I'm going to say treat the first row of in Excel as the variable names. So the first row that we're importing is the 6th row here. I want to make these the variable names. So I can go ahead and run this, and we can look at this data real quick. Okay, so you can see that that cell range has been imported into Excel. Okay, and then once again, we only care about the yearly average, so we're going to say keep year and average, and then we're going to rename average to CPI URS, so it's a little bit more descriptive. And then we're also dropping, there's a couple of missing values, so we're just going to get rid of those. I think it's just for the first year, and since we're not going all the way back to 1978, that's fine. And then finally, I'm just going to save it as a Stata data file because we're going to use it later on here. So I'm going to go ahead and run this whole thing, and now you can see we've saved a Stata data file, and we look at this one more time. And you can see that we have a data set with years down the year in one variable, and the value for the CPI in another variable. Okay, so now all we have to do is merge the two data sets together. When we talked about appending data, basically all we were doing was like stacking the data sets on top of each other. In this case, we actually want to combine these two data sets so that there's a value from the CPI data that gets tacked onto the CPS data for the corresponding years. So if the year is 2019 in the CPS data, then we want to have a value of 380.1 in the CPI URS column. So every time there's a 2019 in the CPS data, we want this value to appear. And so you might ask, there's like a couple ways to do that, but the best way is with the merge command. And the syntax is also a little bit confusing at first, but it should make sense once we run through this. So I had to move this this data down here, the append data after the CPI URS data, just because we actually didn't save this as like a complete data set on its own. So just to like be more efficient about it, I saved the CPI URS data first and then appended everything together. Okay, so then once we have reordered that, we can go over the merge syntax. So the command is called merge, and then the next part is the two types of dataset structures so that we're merging together. So the options are either a many to one merge, a one to many merge, which would be the opposite of a many to one merge, or a one to one merge. And basically what that means is there's kind of like Stata thinks about two data sets when you're merging. They think about the data in memory, which they call the left-hand merge, and then the using data, which we're going to call the right-hand data set. So you have the left-hand data set and the right-hand data set. So in this case, the left-hand data set is going to be the CPS data, because that's the most recent data in memory, right? We've loaded this CPS data and we've appended the 2018 and the 2019 years to it. And then the using data, in this case, is the CPI URS data, which we've just created here with these lines of code. And we know that in the CPS data, there are many values for each year, right? Like we have a ton of values that say 2019, a ton of values that say 2018, and a ton of values that say 2017, because there's a bunch of individual observations for every single year. But in the CPI URS data, there's only one value for every year, right? There's just one 2019, one 2018, one 2017. So that's basically what this M to 1 means. It's basically saying which data has a lot of values in the data in memory, and which data has just one value for every single year. So after the data set structure, we're going to put the ID variable, which is year, once again in this case, oops, and then just the name of the using data. So that's the structure. So quickly, I'm just going to comment out the first part of the analysis so we can just run the second part. Easily. And I'm just going to run all of this up to the point where we merge the data together. So I'm going to run that. All right, and so we can see something happened here. First, we can see that there's a bunch of data that didn't match, which we kind of expect, right? Because the CPI URS data had data from 1978 to 2019, and the data in memory, or the master data, only had data for 2017, 2018, and 2019. So all the years before 2017 obviously didn't match anything. And then, so we can also see that there's a bunch of observations that did match, and we expect that to be all of the years after 2017 and after. Real quick, the merge command automatically generates a variable called _merge with the type, it's just a categorical variable, and it has the type of match or non-match encoded into merge. So you can use that variable to kind of see what's going on. So if we tab year and merge, you can see that merge is 1, 2, or 1 or 2, or sorry, 2 or 3 in this case. So there were no values where it wasn't matched from the master data or the CPS data. There were a bunch where it wasn't matched from the CPI URS data, and then there were a bunch where they did match. Or it didn't, yeah, I think I said that right. So we can just get rid of all of the data pre-2017 from the CPI URS, and a really easy way to do that is just to say keep if merge equals 3, and it just gets rid of those. I don't know if I added this to my do file. Let me see. No, I didn't, and that shouldn't be there. So I'm going to replace that with that. Okay, and then we can get rid of the merge variable now, since we don't care about it anymore. All right, so then the next step is to actually inflation adjust the wage data so that, sorry about that, so we can get an accurate value for real dollars in 2019 dollars. And the formula for that is the value we want to adjust, which in this case is the wage variable, times, this should say 2019, not 2018, times the CPI value in 2019 divided by the CPI data year. So if we were to do this in Stata, we could just like kind of take the value itself and say generate real wage equals something like 380 divided by CPI URS. But this is another like best practices thing. It's actually a pretty bad idea to hard code values like this, where you actually type out the value. Like we know that this is the value, maybe it was 380.1. We know that this is the value for CPI URS in 2019. But when you're writing scripts, it's generally pretty bad practice to hard code values, because perhaps you want to come back to this next year, but you forget to update this value. So what we're going to do instead is grab the CPI URS value directly from the data and use it in our do file. And you can do that with what's called a return macro. It's just another type of macro to get that value. So we can summarize CPI URS if in a specific year, if the year is 2019. And that tells us that the value is 380.1. And then we can access that value with the return macro. So I wanted to display that real quick. The way it works is you put an R and then parentheses, and then the value that we want here is the mean value. So you can display that, and you can see that it returns that specific value. You could also display any of these other values like min or max or OBS. But I'm just choosing to use the mean value here. Okay, and then we can use that in a calculation. And once again, the calculation that we want to recreate is, or the the hard code that we want to replace is 380.1, so we put our mean in our formula here. And then instead of creating a new wage variable, I'm just going to replace the old wage variable. So I'll go ahead and run those two commands. And we can see that a bunch of changes were made now. Basically, that just means we've updated all of the wage values to be in 2019 dollars. Okay. So now we can again run our collapse and reshape commands to get those into a nice format. So I'm going to go ahead and do that and rename all of the output variables to their respective race and ethnicities. So let's just look at that and confirm that it worked. We can see that it did. And then finally, we can export that to a new Excel file, which I'm going to call Ohio wages pooled years. And that's exactly the same as the other export command. Okay, and then I can go ahead and look at that. Yep, and now we could easily create a chart. Right, so that's basically the analysis that I set out to create at the beginning here. Obviously, I formatted it a little bit more nicely in this picture, but yeah, that's how you could pool some data together. A couple of more things that I wanted to go over since we have a little bit of time left here. I wasn't sure we would be able to get to this, but it looks like we will be able to. I wanted to talk about loops really quickly. So say we wanted to look at a few more years of data than just 3. Like maybe you wanted to look at wages since 2010. You can use what's called a for each loop or a for values loop for repeated actions to save you from typing the same code over and over. So like if we use the same method to append all those data sets together as we did before, you would be, you know, copying and pasting this a bunch of times. And then, you know, changing each one of these years to the correct year, which is pretty tedious and especially prone to mistakes, like if you accidentally put 2018 in there twice instead of 2017 and 18. So what you can do instead is use what's called a for values loop to append all of that data together. And so the way that works is, oops, you can load 1 year of data. In this case, we'll load the first year we want to look at is 2010. And then the syntax for a loop goes like this. So you have 4 values, and then a macro name. So basically, 4 values just uses a macro here and automatically declares it for you. And then anything that you put after that, it'll like loop through those commands. So this here, or loop through those values. So this notation here, 2011/2019, is telling the for values loop to loop through all the years between 2011 and 2019. And then you have to put an open bracket, open curly bracket, and a closed curly bracket on the beginning and after all of the commands. And then on the inside, you can just put the command that you want to loop over. So in this case, we just want to use an append command. And again, we're going to use the same macro that we declared earlier to append all of this stuff together. So this is the file path, and then the name of the file, and then we've replaced the the year of the file with this macro that gets declared. So it's going to place, 2011 in here, and then 2012, 2013, etc. And once again, you refer to it as the same way that you do with other macros. So you have the tick mark and the apostrophe at the end here. So I'll just run that really quickly to show you how that works. I'm again going to bring since I'm not running the whole do file, I'm going to bring the local down here so that works properly. So I can go ahead and run that, and it's going to take a couple of minutes or a couple of seconds because this is quite a bit of data. But then if I run the tab command at the end here, you can see that all of those files have been appended together. So that's a really useful way to do things. If you have to do like the same operation multiple times, you probably want to use a for values or a for each loop. And they can get a lot more complex. You can put loops with inside of loops. I just wanted to show like a very basic example, just to let you all know like what's possible. And then finally, because this is like still a little bit tedious if you're going to be using the EPI CPS data all of the time, I wanted to show you a tool that we've created an EPI that allows you to easily load all of the Stata data extracts that I've asked you to download for today in a single command. So you have to install this from the web in Stata, and the way you do that is with this net from command. So net from, and then microdata.epi.org/stata. So I'm just going to copy and paste that from here, just so I don't have to type it out. Data, and this is going to bring up this thing which tells you can download a package from there, and you download the package with the net install and then the name of the package. In this case, it's called load EPI extracts. So net install load EPI extracts. Okay, and so I already have it installed, but if you don't have it installed yet, it will install that. And then the syntax is like this. So you type load EPI extracts and then a comma, and then a begin date, an end date, and the sample that you want. In this case, this would be the org, and then the directory that you have the data in. So let's go ahead and show you an example real quick. Load EPI extracts, begin 20, let's just do the same data that we just loaded, M1, and it has to be this very specific kind of date time format. So it's year and then M and then 1 through 12. So end 2019 M12. Sample is the org sample once again, and the source directory is C data/CPS for me. So wherever you stored all of that data on your computer, you just put that directory in this option at the end here. And instead of typing a whole loop with maybe a macro, I could just do all of that really quickly with a single command. So if you are planning on using and I'll just confirm that works. So it's like tab year. So if you're planning on using the EPI CPS extracts a lot in Stata, you should definitely install this command. It's very useful. And there's also an analogous version for R, which we can talk about a little bit if people are curious about that, and we can send out some information about that. But the one for Stata is a little bit more mature. I'm not sure if the R one is 100% ready to be shared. If it isn't, we will be able to share it soon. So, but I just wanted to show you this because if you're going to be using the EPI extracts a lot, this will make your life much, much easier. And then you can also, there's another option that you can add to the command where it allows you to keep specific types of specific variables. So say you only want a certain number of variables, you can just load those variables to save memory on your computer. Okay, so that is the end of my presentation for today. So I just wanted to open it up really quickly to questions, if anyone has them. Feel free to write those in the chat or just say them out loud. And let me open this. So someone has a question, can you talk through the difference between when you'd use for each and for values? Sure, so for each is kind of just like a general version of for values. Because I'm looping through numbers here, whoops, in the do file, I'm looping through numbers. I can just use the for values command. But say I wanted to loop through something else, like if I wanted to loop through like string values instead of numeric values, you could just use the for each command instead, and I'll just bring up the help file because it's pretty useful. So the syntax is slightly different. So it's for each local name in a type of list. So you could use it to loop through numbers as well. It's just a different syntax. So instead of for values year equals 2011 to 2019, it would be for each year of num list 2011 to 2019. So it's just like a slightly different syntax, but you can use for each to loop through all kinds of things, not just numbers. Okay, and then another question is, I'm new to Stata, and a lot of what I've learned I've connected to what I know in R. Do you foresee a problem with thinking in one language in terms of another? So I also use Stata and R, and I guess when you're maybe first learning, sometimes it's easy to get the concepts or the commands confused, but really like it's pretty straightforward to switch back and forth between the two. Once you like get in the mindset for one, it's pretty straightforward to stay in that mindset, and a lot of the concepts are like the same, so it's actually useful to learn concepts in R and Stata because you kind of get a better understanding of how the concept actually works with a different syntax. So yeah, I think it's useful to learn both languages. How long will the Data Bootcamp GitHub download page be available after EarnCon? We'll leave it up indefinitely, so you can always go back to it, or at least till next year's EarnCon. Oh yeah, and then so thanks for posting that cheat sheet, Jory. I've also at the end of these slides here, I've posted a bunch of pretty useful resources for learning Stata and some links to the EPI microdata website. So also be sure to check these out if you want to do some more Stata learning on your own. Do you have any go-to references for using CPS survey weights in Stata, especially differentiating between when you use which? So the go-to well, I'll just tell you what I do. So basically the CPS survey weights, well, actually, let me clarify. Do you mean which weights to use, like which variables to use, or which type of weights to use, like probability weights or A weights, analytic weights, that kind of thing, types of weights? Okay, so typically the only place where it matters, generally speaking, there's a couple of nuances to this, but if you're trying to calculate like population counts. So if you wanted to count up the number of people in Ohio, you have to use, like in the collapse command, I used analytic weights. But that wouldn't actually give me the number of people in Ohio if I were to count like the sum of like a population variable or something, for example. You would have to use probability weights. So generally speaking, it's just best practice to always use probability weights. And if you're calculating means or anything like that, it doesn't make a difference. But if you are calculating counts, it makes a big difference. So just generally use p weights, except for you can't use p weights in sum. So you can use a weights there, but you never calculate counts using the sum anyways. So that's generally the rule of thumb. I don't have any specific go-to references on survey weights. I'm sure there's some articles out there, but no, I don't have like a go-to reference. I just typically use p weights, just so that I don't accidentally screw up when I'm trying to calculate counts. So Dustin, the weight variable, when you want to, so in this case, you could use the org, basically the org weight, if you're using the org data, adds up to the total population within each month. So, or sorry, within, I think it's within each month, right? Is that right? Asking Julia and Jory here. Like you have to divide it by 12.
I turned my video on, sorry, instead of unmuting. Yes, monthly weights.
Okay, I just wanted to double check.
Yeah.
I'm pretty sure
For the
it is.
basic, if you're using a different sample, like it's a year. It just depends on what sample, but for the basic, yeah, it's 12 months.
Yeah, basic and org. So if you're using the org, you can use the org weight to calculate the entire US population. And the way you could do that is you could collapse by, you could collapse the data set by month and year, and that would give you the population within each month. If you wanted to collapse it just by year, you would divide the org weight by 12 and use population weights. And then if you're using the basic data set, which we didn't talk about, we only use the org here, but it's essentially just 4 times larger than the org. You would use what's called the basic weight in that case to calculate populations. And yeah, and Julia linked a useful methodology document on the microdata website. Any other questions about Stata? Or I could also talk about like some of the stuff about best practices and project management and that kind of stuff. Okay, well, if there are no more questions, then I just want to remind everyone to please fill out the evaluation for Data Bootcamp, because we really do use that to make improvements on the sessions year on year. And you can always feel free to email questions to me if you have any about the materials from this Data Bootcamp, or you can also email the Earn listserv about any Stata questions. There's always people on there who are very willing to help out with Stata questions. And yeah, thank you all for attending Data Bootcamp this year.